The desire to explore the unknown, never-ending universe has led to the discovery of the new planet, Venus. Apart from the name, very little is known about this planet. Previous investigations have reported that hills and cliffs are present on the surface. Driving into such a cliff means the definite loss of the vehicle. For further exploration of this mysterious planet, a space agency had a request for two highly technical advanced robots. We are proud to present to you Bert and Ernie. They will be sent to Venus with the mission to retrieve rock samples. Because signals from Earth would take too long, the vehicles must drive autonomously. On Venus, the two robots will be placed together with a lab to deposit the samples. Hills and cliffs must be avoided, and also a collision between both vehicles cannot happen. This raises the question, how will Bert and Ernie complete this task? So before the footage on Venus, a brief explanation of the robot's equipment. To start with the wheels. The 90-degree turning angle is determined by rotating the servo motors for a specific time. The IR LED and receiver are used to track the covered distance. This information is later used to find back the lab. The infrared sensors to detect the borders and cliffs on Venus are placed directly in front of the wheels. When searching for rock samples, the robot will drive forward so Bert and Ernie cannot fall into a cliff. 3 IR emitters are used in combination with a receiver. The side of the receiver is blocked to make sure only reflected light will have an effect. In front, the gripper is extended with a funnel to increase the reach. The IR sensor for detecting the rock samples has 4 emitters and 1 receiver. Rock detected, Bert and Ernie will drive a small distance backwards for the gripper to pick up the rock sample. The ultrasound sensor at the top is adjusted in such a way that the robot can turn just before it would hit a hill. The installed compass appeared to have a large error due to an abrupt change in the magnetic field during a turn of the robot. Eventually, it is excluded from the system. Bert and Ernie can get so excited that they have the tendency to tip over. This counterweight will prevent this. Due to a shortage of space for the IR sensor beneath the gripper, a part of the circuit is placed on the side of the robot. Besides the equipment for the mission, Bert and Ernie have a special strategy for finding the samples. Here is an animation to explain the so-called pathfinding algorithm. Independent of the lab's orientation, the facing direction of the robots is set to be the y-axis. After making a 90-degree turn, the robot would drive along the x-axis. Using the distance traveled measured by the sensor in the wheels, Bert and Ernie will always know their location relative to the lab. This ensures them not to get lost on this unknown planet. First, Bert will go straight and Ernie will make a direct turn to cover a different area. The robots will zigzag over the surface by making U-turns. When a U-turn cannot be made, the robots turn a full 180 degrees and drive back to try again. All sensors are in front, which makes driving backwards too risky. Ernie follows the same zigzag procedure as BERT. When a rock is found, the robot first matches its y-coordinate and then its x-coordinate with the entrance of the lab. The spaceship has landed and both robots are fully prepared for their journey. BERT drives straight from the lab. Looking through his eyes, no rocks seem to be found yet. Here, a perfect U-turn can be seen, followed by another one to complete the zigzag move. The ultrasound prevents a collision. Phew, that was close. And again, a second hill is being avoided. Finally, a rock. A full turn is made to match the y distance with respect to the lab. The sensors in front of the wheels detect the taped edges of the ramp and the robot drives safely into the lab. And now it can drop the first sample.